dress like a gent. Said well, get up and go, must have got and went. Girl, I got good news, she's a real good liar. Goes to the backstage, girl, you set your pants on fire. Just a little too far. You're telling other things, but your girlfriend lied. You can't catch me, cause the rabbit done died. I guess it did.
All right, good afternoon, ladies and gentlemen. I'm Bill Hamblett, the Editor-in-Chief of Proceedings at the U.S. Naval Institute. It's my pleasure to welcome you to this afternoon's panel discussion, Beyond Shipyards, Scaling the Fleet Through Innovation. Before I hand this over to Michael Stewart, just wanted to remind you all that AFCEA International and the Naval Institute would like to recognize all our industry partners who make this event possible through their generous sustainment and sponsorship. Without their support, events like WEST could not happen. Please spend time walking the floor and seeing the amazing technology that all these companies have to offer while you're here this week. Now it's my pleasure to introduce the moderator of this afternoon's panel, Mr. Michael Stewart. Michael is the former director of the Navy's Disruptive Capabilities Office. He also served as executive director of the Navy's Unmanned Task Force and chaired both the NATO Tri-Service Main Armaments Group and the NATO Naval Armaments Group. A retired Navy captain and naval aviator, Michael has also worked in senior roles at the Office of the Secretary of Defense and the Navy's Integrated Warfare Office. Before returning to the Department of Defense, Michael was a senior manager in venture capital and a member of an internal consulting team for the Boeing Company. He's a graduate of the U.S. Naval Academy, the Handsome Powerful class of 1987. He holds a master's degree from the Naval War College and an MBA from Harvard Business School. Michael and panel members, thanks for being here today. Michael, the panel is yours.
So thank you very much, Bill, and exactly 87, go Navy. Thank you for WEST and the Naval Institute for hosting this. Thank you guys for showing up on a rainy day in San Diego. This is my hometown, flying out from DC, so I'm thrilled it's so rainy. But I'm looking forward to this panel. And let me just sort of frame what we're going to talk about. You've heard the CNO, you've heard a lot of discussions talking about how we've got to build the industrial base, a lot about shipyards. And the question really becomes, if you're working on shipyards, is there something else you can do in addition to the shipyards, right? So we're going to talk about how non-sort of traditional defense companies or non-traditional companies can contribute to naval capability. But before we have that discussion, I'd like to just frame the discussion for you with a couple of slides. So on the left-hand side of that slide is essentially the problem statement. If you want to build naval capability, how can you do it in addition to the traditional ship types? On the right-hand side, that's a chart that's probably kind of familiar to you. You'll see that on the bottom, that's essentially Chinese combatants, and those are ship counts. On the top, that dashed line is essentially the U.S. fleet, and you'll see the Chinese are building up into the numbers of the U.S. fleet, right? To put a finer point on it, same thing. What this chart is showing you is that the PLA Navy and the U.S. Navy battle force ships from 2000 to 2030. The red circle, what that's trying to show you is, in the beginning on the left-hand side, it's showing you the U.S. fleet count above the Chinese, and you'll notice that it inverts around 2020. So the Chinese are outbuilding us, right? And if you notice on the left-hand side, those are pretty traditional ship counts of pretty traditional ships. And of course, that's elicited a reaction from, if you take a look at, there's a presidential executive order essentially saying you've got to go faster, you've got to supercharge the maritime industrial base, you've got the NDS, which is saying the exact same thing. And then you've got the CNO coming in and saying, look, I need a golden fleet with essentially a main battle force to deter and win in the 2030s, but I also need tailored offsets, right? That's what this panel is really going to talk about, is sort of the tailored offsets in addition to ship count. But while we're doing that, I'd like to actually throw something out to you for you to think about. How do you define naval power, right? I know that we think about ships a lot, and the ship counts a lot. And I'm not trying to be funny or glib, but in the era of Mahan, maybe ship count really mattered in terms of you had limited sensing beyond the horizon, you weren't networked, ships contained their own sensors, and there was a fleet-on-fleet engagement. Completely rational to do ship count. But the problem is, if you look at Russia-Ukraine, and before you groan and eye roll that Russia-Ukraine is not the entire thing, it tells you something, because if you look at the order of battle for the Russians against the Ukrainians the day before that battle started, if you were doing ship count, the Russians should have completely destroyed the Ukrainians, and yet the Ukrainians with no navy essentially destroyed the Russian navy in the Black Sea. So what does that mean? So if you go to the top right, perhaps you can start expanding the definition of naval power. And because you may not be able to read it, I'll just read it for you. And feel free to rip this apart. This is the Naval Institute, so we can think great thoughts and drink Merlot or port or whatever. So in an era of persistent sensing and area denial, naval power is measured not only by ship count, but also by the ability to be present from the outset, to sense, operate, deny, and deliver effects across maritime battle space, including highly contested environments, and to sustain those effects across the full continuum of conflict. And that's what we're going to talk about, and that's why the folks on this panel are up here, okay? So before we get started, I'm going to introduce the panelists going right down the line. So firstly, you've got Sebastian Grahl. He's CEO and founder of DRIX, a naval architect and a designer. He's been building unmanned surface vessels for persistent maritime sensing. Next to him is Ryland Hamilton, CEO and founder of Blue Water Autonomy, developing autonomous maritime systems for distributed naval operations. Then you've got Laura Hooks, Vice President and General Manager for Maritime and Strategic Systems at General Dynamics Mission Systems. Then you keep going down, you've got Nathan Michael, Chief Technology Officer at Shield AI, focused on autonomy and AI for contested environments. You've got then Greg Ostron, from General Manager for Networking Data Link Solutions at L3 Harris. And last but not least is Rear Admiral Doc Scholl, former Blue Angel, Rear Admiral retired. He's the Executive Vice President for Defense Partnerships at Kraken. So with that, I'm going to go right down the line. I'm going to assume that panelists, you probably agree with this new definition of naval power, and I'm going to ask you really two questions. What do you contribute to that naval power? Like, what are you bringing to the table? And secondly, how are you bringing it to the table?
First, we've been shipbuilder for the past 35 years, delivering ocean-going vessels to all sorts of customers. And our Oryx, our USV, have been around for the past 8 years. You can think about them like autonomous trucks on which you can install any payloads, whatever payload is needed for your mission. Can go to. We've started developing them for the commercial applications. For instance, NOAA raves about it. We've developed this range. Whatever the mission, we have a proven platform. And as you can see, the platform being proven for commercial applications, we've been part of all sorts of exercises, you can go, for the past 4 years for Navy's application. And so, how we can contribute? We have those Oryx. They have been there for years. We have many of them. And they are essentially an autonomous truck. You can put them where you don't want to put a manned vessel. You can send them into GNSS and communication-denied environment as they are truly autonomous. And by the way, Exail is a navigation and PNT company. You can send them where you need persistence. You want ISR, you want MDA, you want ASW. It does all those things. And by the fact it's not hypothetical, it's already done. We have production facilities in France. We built in composite. The composite brings very low cross-radar section. It doesn't require any maintenance on the structure. And it's very, very easy to industrialize. On that matter, we are really looking at mass production now, and we will be able very soon to deploy new production lines in foreign countries and applying the methods that are already applied in aerospace manufacturing. So we are an experienced shipbuilder. We've been there for years. We have the capacity. And tell me how many you want, and you'll get them soon.
Sounds good. Rylan?
Great. At Blue Water Autonomy, we're focused on designing and building what the Navy would call medium unmanned surface vessels, and we're focused on a program called MASC, which is a Modular Attack Surface Craft. It's a multi-mission vessel where we can carry different payloads on the back. Think about 4 40-foot containers. It's not meant to replace the manned fleet or the surface fleet, but to complement it. The point I want to call out with this slide is that when you build unmanned surface vessels, whether they're small or the medium, we're not taking away from capacity at some of the large Navy yards, whether it's NASSCO or Bath Iron Works or Ingalls. These vessels at the medium size are like plus or minus 200 feet, and they actually can be built at commercial yards. And these commercial yards have capacity today. So at the top left of the slide, when you build an unmanned surface vessel, and if you think about a ship, well, you basically have the platform or the hull, and then you have a hotel on top to house the people and the sailors, and then you have the payloads. Well, when you remove the hotel, you actually simplify the ship a lot. So you don't have to deal with things like gray waters or the accommodations or the bridge or berthing. And then you can also build these vessels to commercial standards. So you don't have to build them to be as survivable as a DDG because you don't have people on board. So that really simplifies the design and also lowers the cost. There's also all these commercial shipyards, and so they're on all 4 coasts, whether it's the East, the West, the Gulf, or the Great Lakes. We have a lot of these facilities, and obviously they all have different capabilities and sizes. But let's say there are 100 plus of these. So they also, for these facilities, to build something that's 200 feet, you don't need the same infrastructure that you do to build the destroyers. And so for these yards, some of them, if you look on the right side, and here are 2 examples, can build over 20 or 30 of these types of vessels per year at some of the yards, without taking away from capacity for some of the large manned surface combatants. And so it's not that hard to think about surge capacity at these yards, so the Navy doesn't need to invest into the maritime industrial base, that if you ever had to, you can build 100 plus per year. We actually just announced our kind of lead vessel in this. We're calling it the Liberty class, which kind of goes back to the Liberty ship, which again was built at many different yards. It was designed to be easy to build. It didn't have the same standards as some of the manned surface combatants, but it's something that we could pump out in volume. And so I think when you think about unmanned, we have the ability to build a lot in a short amount of time. They can carry some of the payloads and have some of the effects that you do have on the manned surface combatants, and it can complement the fleet in a way. And when we talk about timelines, we talk about months and not years.
Sounds good. Laura?
Sure. So naval power requires mission capability from subsea and seabed warfare to space. And that's what we do at GD Mission Systems. You really need to be able to work and integrate across all of those domains in order to ensure you stay operationally relevant, especially for contested environments. So what do? We bring cyber secure solutions to all comms and data links, enabling resilient networks across every domain for those denied environments. While our sister companies, Bath, NASCO, are truly the platform providers, we focus on providing the mission systems that make platforms relevant. So that includes combat, weapon systems, sensor integration. And for example, our systems are responsible for command and control and launch of pretty much every payload on a submarine. In order to scale, it's pretty clear we need to be able to extend beyond the traditional submarine and surface platforms that exist today. We do that by providing autonomous system integration for manned and unmanned platforms. We're focused on rapid delivery of low-cost effectors to create affordable mass, and creating attritable systems that are, call it 80% solutions, and enabling kind of that metric-centric warfare for the denied environments. We've got a proven track record, so you asked the question of how. Scaling deployable, modular, open systems and moving fast. So whether you're thinking about new mission capability like hypersonics, or integrating existing capability like Navy strike missiles, or rapidly prototyping low-cost effectors, we all need to be delivering capabilities for hybrid and distributed operations that support the Navy's hedge strategy in order to build naval power.
Okay. And then we've got Nathan.
Great. Within Shield AI, we're focused on building the intelligence that enables one or many systems to be able to operate in the most challenging and contested environments. When I think back to the slides that were shown a moment ago, and we think about going from per hull count to systems that have the ability to really think for themselves and operate in those degraded and denied conditions, I think about network effect metrics, where we really pursue area sensed, kill chains collapsed, and dollar per fire. And we really think about how can we drive increased performance metrics across autonomous and intelligent systems in order to be able to operate as a team and to build that future intelligent fleet. Right now, when you think about autonomous platforms, largely they provide what you might call platform autonomy within the maritime domain. So you could think about collision avoidance, coal reg compliance, and station keeping and similar. However, those capabilities do not really drive toward those network effect metrics and really improve that performance at a fleet scale. What we need are capabilities that enable commander intent, adaptation of behaviors to perceived and detected threats, as well as coordination across assets, both in the air and at sea and beyond. Within Shield AI, we've built out HiveMind, which is our mission autonomy platform, and have deployed that across many different classes of systems and across domains, including uncrewed jets and uncrewed helicopters, to integration through work with partners like HII and similar onto surface vehicles. So to what we're doing now, we're working with a greater group of partners to be able to integrate single and multi-agent capabilities to operate in contested and degraded and denied conditions, where systems are able to work together to search areas, identify targets, queue sensors based on prioritization, and ultimately collapse that kill chain in order to achieve improved mission effect.
Okay, Greg?
Yeah, thanks for having us here, Michael. I was excited to get invited to speak at the forum today. L3Harris is a defense technology company with a broad span of capabilities. It ranges from solid rocket motors that go into weapon systems. Standard missile is one example. Aircraft modernization, aircraft sustainment, P-8A Poseidon is one of those that we're doing today, all the way to communication systems, which is really more in the area that I operate in within our spectrum superiority sector out of Salt Lake City. So I think one of the things, our role in this forum is to provide a ability to create that network effect that allows us to scale those effects that we talked about, or we will talk about, across the fleet so that we can see that, that ultimately achieved. And then one of the things too that I wanted to hit on is the fact that L3Harris has really leaned forward in this area by investing in a number of small companies. Shield Capital is one of those. And we do that by to leverage the technology that they're creating, pulling it into our products. We do a kind of a make-buy decision that allows us to deliver a capability to the warfighter in a much timely manner.
And Doc.
If you could do me a favor at the back table and go back to Michael's slide, because I'm going to agree with both.
Which slide?
The slide you had up with the question, sort of the both sides, the two questions. And the reason why I do is we're in a conundrum right now where I want to use sort of C denial and C control. I'll use a couple doctrinal terms, where we saw a great example of a unique disruptive system in Ukraine that created C denial across the greater part of the Black Sea, and where they needed and wanted it in that grain corridor on the western side of the Black Sea, sea control, where they could use and maneuver at will. So if we had that exact example, and we were able to push forward overall as a nation or with our allies, I would say that we are in a good spot, and I would agree with the second part of the slide. But we sit in a different space right now where we're in a conundrum of three different doctrinal terms. Those are force design, force development, and force employment. And I listened to the CNO talk. We're talking about force employment, so I don't believe that we're in a force development aspect, that we're trying to drive a change in force design. We're trying to drive a change in force design inside of the force employment window. And the force employment window is inside of our certification process, which is about a little over a year. You can stretch that out to 18 months. So then what do we need, and what does Kraken Technology Group do for the US and our allies? I would say if we could use the example of Europe, that example where they have a forcing function of a threat that is active, they are taking action and moving forward. Force design, we need effects-based activity today. And so that's what they're looking for, and that's what they're executing to. Here, we find ourselves in the conundrum where we have to have a change in culture to drive our acquisition, operators, and the system between it. We're making a lot of different changes. I really hope that those take a lot of traction, but we need to develop what I would call volume or scalability. That scalability is going to come inside of the end of the force development window or in a force design window, based on shipyard capacity and builds. By that I mean big steel, developing the number count on the left, the ship count. When we look at the sort of the new definition on the right-hand side, that scalability has to be with innovative partners that drive a modularity to the system, with partners like Shield and with other partners in the system that have an ability to be plugged in both in a sovereign capability and in a even in our services, where we have challenges inside of our command and control and signal, where we have to integrate so it's a single picture to the mock. The other part is, when we get into that of the scalability, they have to have the ability not to have complex flooring for rotating machinery inside of large structures. We need to take a facility about this size and be able to produce 500 vessels a year. So that's what I talk about in scalability, where quantity has a quality all of its own to create a deterrent effect. The deterrent effect is going to have, it has to be credible, you have to communicate it, and it has to be a capable system. To be able to do that against our adversaries, we have to be forward-based. Forward-based and show them every day what that is in terms of a persistent presence. In terms of all unmanned systems, there are several great communities and developments in a lot of different companies that are able to produce that persistent system that can put a message to the adversary that makes them think about taking that next step. Or, in the thought process we like to speak inside of the US think tanks, which is hey, maybe not today. And so that's what we need to push and develop. The last part of that is we have called it in the past in the think tanks, access basing and overflight. In this case, there has to be, we can't bring these volume on ships. This volume has to be based close to be that persistent threat or that persistent presence that's developed. So Kraken as a group, we have the modularity both in terms of software, we have the modularity in terms of payload, so a multi-mission capability that within 10 minutes, our vessels can have a kinetic effector to an EW, to an ISR, to the very non-sexy role, which is a logistics payload. High speed, critical parts to be delivered to the time and place of your choosing. And then the scalability part, literally the size of one of our 3 facilities is this size for our smaller vessel that is pumping out 1 a day in about a 12-day process on 2 assembly lines, and they're feeding that area inside of NATO that I think would be a great example for the US to look at if we want to move now and create capability in volume that's going to add to the right side of that page, not take over mission sets, but drive a ship count or a capability count that is going to create a conventional deterrent. Thank you, Michael.
Sounds good. I'm going to do an audible really quickly, what you guys said, and anybody wants to jump in here. So let's say CNO is listening to this, and he's like, these guys have a point. How would you quantify the right-hand side, and how would you budget to it? Anybody want to take that really quickly?
Sorry, did you say the left or the right?
Say again?
The left side or the right
The
side?
right side. I think everybody can look at ship count. So if you heard him talk about his unmanned strategy and his disruptive strategy, he said, I'm not sure we're there yet. And so I think the question is, how do I budget to it? What's enough?
I'll get us started, maybe. So when you think about our unmanned strategy and where we are positioned, I would say that operationally, we are seeing engagements and continued sorties in contested and degraded environments in Ukraine 24/7. We're deploying these systems across not one, but many different platforms. In some cases, they're working together. I think that we are much further along. And so from a budgeting perspective, the focus becomes, how do we operationalize physical AI? That is, the AI applied to physical systems operating in the world. How do we enable that integration across a variety of different platforms? Ultimately, what you see in the market right now is some platform providers are working with companies like Shield AI to create this integrated mission autonomy strategy. Others are vertically integrating and creating their own proprietary solution. So how do we navigate the fact that you have this landscape of many different types of and approaches to autonomy and bring this together into a consistent framework so that you can have that common intelligent fleet? But from a fundamentals perspective, in terms of how do I coordinate a team of agents in an operationally relevant environment, even though it is the case that there are certainly significant challenges in the maritime domain, the connections between mission planning and physical platform characteristics, the connections between sensing and perception to how the systems actually operate in that environment and the challenges therein. Those challenges are being worked through. So now we have to really think about how do we tie those systems into a broader ecosystem so that we can lift that back to the command and control picture and tie that into the decision making that is operating at the commander's level.
And maybe just building off that, I think, simple metrics, I think, is what you asked for, right? So cost per effect, time to adapt, and success rate, whatever that success is, right? I think those are the types of metrics we've got to get to.
I agree. Rylan?
And Michael, what I was thinking about when we had spoke about this previously was when I really focused on the word effect. And I think that that's what the Navy has to determine is what is the effects that they want to have on the adversary on a target in relation to the way that they used to look at it from a ship count. They looked at a number of tubes, number of weapons that they could put on from a kinetic perspective. Now we look at it from a total effect perspective. So depending on how the Navy is going to go fight the adversary in whatever domain it may be, they have to determine the effect. Then they can kind of back plan from there and determine, okay, what do I need from a sensor perspective? What do I need from a shooter perspective? How am I going to jam an adversary? That can then kind of help us back plan and determine really the number of holes that you're going to have. Am I going to be airborne? Am I going to be under the sea? And then we can kind of probably do some more financial planning that way and really help the Navy achieve what they need to.
Yeah. To your question about how the CNO should budget for this, he doesn't have to because there's budget out there right now. And I think some of the biggest pitfall would be, if you're too risk averse, because there are going to be some failures that happen when you put these platforms out into the fleet, and also experiment. And so, for instance, Shield AI builds some of the most capable UAVs that are out there of different sizes. And then it wouldn't be crazy to think that a Blue Water or some of the other providers that could make the platforms or the medium-sized USVs that could carry these UAVs into different areas and kind of extend their range. And so I think the experimentation needs to happen. The budget is there, and then be open to see what can come out from the fleet.
Okay, Doc.
So I love Ryland's comment, but I want to add to something that if I could advise the CNO on something with the money that he's already got, it is not just the platforms, because if you've been to see what's in Ukraine, there's a lot of platforms in storage areas. We have to, when we talk about purchasing at volume, we also have to talk about scaling the life cycle, or what I call, scaling the phase of sustainability for that weapon system or that capability across time. Because that's where we're going to find the most friction. We're going to either have the greatest toy for a short period of time, and then that's it. But if we have to, he has to be able to think and fund and work with the folks here on this panel and the companies in the industry to develop that, because we're inside of that window of force design where we would help them, or they would create all that in our acquisition system and drive towards that exquisite capability. We need to drive that down into a shorter window, into a shorter time frame, if we're going to be ready in any way, shape, or form inside of the Davidson window, which is coming up rapidly, and we're still doing a lot of thinking.
I think that's actually an area, where traditional defense can be partnered very well with non-traditionals, because typically non-traditionals can go a little bit faster. You've got a little bit less rigor behind it, and we can help the scalability to really get something out there. You can get it out there quicker in a smaller quantity, and we can help ensure quality, long-term sustainability, operational availability once it does hit the fleet.
Yeah, the connective tissue to the broader ecosphere of that sustainability, I would agree with that wholeheartedly. We're going to take over the conversation, Michael.
Stuart, you've lost control. So one comment I would make to you is certainly, if you look at that definition of sort of the continuum of the conflict, I would agree with you that, if you think about some of the stuff, this is an editorial comment, is you've got to be able to go immediately, have a deterrent that's credible, and then as one of the senior leaders once said, give me speed bumps to slow down so then we can scale, right? So agree with you. Okay, I'm going to ask you guys some individual questions. I'll start with Sebastian. Sebastian, you come from a non-US company that has fielded autonomous maritime systems at scale outside the US Navy for a pretty good time. What lessons from that experience translate directly to scaling persistent maritime sensing faster and at lower cost for the Navy, and what does not translate so easily?
I would say focus on what we believe are the three pillars of successful autonomy at sea. So the first one is naval architecture matters. At the end of the day, we're talking about boats, and relatively small boats that you will send in extreme conditions where they have to perform to be stable in waves higher than the length of their hull. The second point is reliability. That's not an option. You can't buy it. It requires experience and years at sea. What's frustrating about different exercises we've done, they are not testing reliability. It's easy to prepare an asset to do few hours in calm water. It's another stuff to put a boat in the blue water for 30 days without any human intervention. And the last point is open architecture and interoperable software backbone. And it must be ready for ultra-agile improvement. you need to adapt to the mission very, very quickly. And if you want to do that, you have to thought about it from day one. As an example, we have been integrated into 5 different command and control systems or combat management systems, including Minotaur, and we've done that in less than 2 days. So really, open architecture is a mantra.
Rylan, so earlier efforts, and for those of you who don't know, Blue Water Autonomy is competing for the MASC. So earlier efforts like the MUSV and LUSV were built around fairly prescriptive requirements, while the MASC reflects a shift towards more open, problem-focused approach. From your perspective, how has that affected the way you can bid? How's that affected Blue Water Autonomy, how you engage with the Navy, and how does it influence innovation more broadly in this space?
Yep. So I hope the Navy's approach to MASC becomes a case study, but I think we're still too early sort of to claim success. But it was only last summer that the Navy had Industry Day, and they gave a very strong signal to industry about what they wanted. And then you had multiple companies come in and compete, offer commercial offerings, so that it took direction from the Navy, but didn't take, as you said, a prescriptive kind of approach and say, here's the book of exactly what we want. So we're going to get 80, 85, 90% of the way there in terms of what the Navy wants and needs. And within 18 months, you're going to have multiple companies launch. So like new builds all the way from the keel up and put vessels in the water that the Navy can then use. So that's pretty fun. That's not from like contract award. That's literally from Industry Day saying, here's what I'm looking for. And then 18 months later, you have all these different vessels that you can go test with. And by the way, most of these companies, if not all of these companies, are taking risk. They're putting their own capital into the development. They're developing the technology. They're building ahead of schedule. They're building up manufacturing and kind of capacity within the maritime industrial base. And so maybe if we're halfway through kind of this process, I think it's a really good playbook about how to approach some other kind of concept that the Navy is thinking about. Now, it wouldn't apply to like a guided missile destroyer in terms of how GD approaches building them at like Bath Iron Works. But when you're talking about things that cost millions or tens of millions of dollars, like it's okay to experiment and to focus on speed and schedule and get things into the warfighter's hands. So, I think credit to the Navy for giving that demand signal, and credit to industry for moving quickly to get holes in the water.
Laura, what does good enough look like when innovation speed matters more than? What does good enough look like when innovation speed matters more for contested environments than perfection?
Yeah, so I think this gets back to kind of the Ukraine discussion that we were having as well, right? How do we innovate to stay ahead of the threat? Or as we heard yesterday, how do we innovate to dominate? And that is the commercial and small business kind of mindset that we're all embracing to try to move fast. I think we're seeing this on MASC, we're seeing this on landing ship medium, where you're taking kind of a commercial baseline and building from it. You're trying to suppress requirements, from change perspective, but then figure out the right time to spiral changes in as you learn, as you test, as you deploy, as you get operational knowledge about how to use the systems. So, how do we do that? We do that by kind of embracing a disruptive mindset that comes from some of the small businesses we've acquired over time, with Progeny and Bluefin as 2 examples. And we focus on that rapid prototyping and the testing and the learning and try to learn how to update in real time as we go. Modularity matters here. You need those open systems, as Sebastian mentioned. You have to have that so you can architecturally construct things that are best of breed, even if you didn't design them yourselves. And a caveat a little bit is that speed matters greatly, but it doesn't matter if you can't keep the warfighter safe. So you need to consider weapon system safety and platform safety, particularly as some of these unmanned systems may have to be transported on manned vessels to get into theater. So you need folks that have that innate knowledge to bring that weapon system safety perspective to the commercial side. So I think the Navy is handling wartime threats all the time. Although we're collectively trying to go faster, we're still not going fast enough. I think we all feel that. Figuring out how we bring the best of breed capabilities and the partnerships between the non-traditional defense businesses, along with the traditional defense businesses, will help move things faster. And we've got to get that speed to capability mindset, across the board. I think we have to think about changing acquisition strategies to embrace the OTAs. We're seeing a lot happen now with OTAs that are moving things in the right direction, and commercial contract structures as well, to get to that 80% solution that focuses on what's operationally relevant and how to adapt quicker. And that's going to be the things that accelerate the capabilities to the fleet quicker.
Nathan, in the Black Sea, we saw what low-cost unmanned systems could do against a larger fleet, but most of those were remotely operated or single-use. What changes when those systems can operate autonomously and can coordinate with each other in a contested environment without relying on constant connectivity back to the operator?
Well, the operational model changes fundamentally. You move from, as was just noted, a one-to-one relationship where you're teleoperating or remotely operating those systems to a team of agents that are able to work together and to drive collaborative outcomes. This directly impacts those network effects that I noted earlier in terms of, as was called out, the cost per fire, the efficiency of area coverage, and greater levels of awareness toward area denial. We are seeing in our own right, as we deploy these types of systems in the air domain, significant asymmetry in terms of cost and effectiveness. You're talking $1 million enabling $200 million of outcomes in terms of destruction of SAMs and similar from an air domain, and currently partnering with vehicle providers to bring the same into the maritime domain. Fundamentally, to achieve these outcomes, we need to be able to develop not just individual agents that can think for themselves, but teams of agents working together under these contested environments, able to sense, to operate, and ultimately to coordinate to affect the mission outcomes. But to the original question, it just fundamentally changes the operational model and how we think about deploying these systems and empowering these systems to think for themselves to achieve the mission.
I'm going to ask you one other question. Just a panel I did a few weeks ago. I showed a picture of, and this is for Nathan, I showed a picture of the Ukrainians and the Russians were using fiber optic cable to control their UAVs. Where do you think we are in the continuing to move beyond fiber optic cable to actually allow things to go do some things autonomously?
Well, systems are doing things autonomously today. I mean, we have platforms that are being deployed in Ukraine that are able to observe and understand the environment and then make decisions based on that. Of course, when you're talking about smaller quadcopters where the level of investment and the total technological requirements dictate something like a fiber optic cable, it makes a ton of sense. But when you're talking about teams that are surveying over large areas and then coordinating and working together to achieve targets and strikes that are seeking to achieve levels of higher efficiency, that's happening at this time. Of course, there's a lot more to be done, and we're partnering with various providers of platforms, particularly in Europe, in order to enable them to coordinate together across different types of platforms, different cost models ranging from lower cost one-way attack drones to larger systems that can engage in more of an ISR context, integrated and denied environments. But obviously the state of the art is advancing, but it is the case that today we have platforms and systems out there that are really able to think for themselves, make decisions, coordinate, change what they're doing based on what they're observing, and seek to optimally support mission and remote fires accordingly.
I'm going to keep on going, but don't be surprised if I circle back about the legality and the policy of where you see that. I'm going to go to Greg. So as the Navy moves forward towards a more distributed hybrid fleet, what problems must be solved first to enable non-traditional innovation to scale reliably across platforms?
Yeah, I've touched on some of those already. I think particularly as we start scaling some of the technologies that Blue Water and Shield are talking about, it's going to be effectively producibility and scaling that. And I think that's where non-traditional can come in. And that really starts now with interoperability, because there's going to have to be some sort of, at a minimum, command and control with our legacy Navy and our legacy systems. So I think that's an opportunity where we could come in. And then ultimately producing and scaling their production capacity from, say, a small quantity, wherever that number may be, 5, 10, to hundreds. And I think there's going to ultimately need to be a lot of rigor put in early on to ensure we meet all the ILITs: producibility, manufacturability, reliability. It ultimately results in operational availability, because if we don't have operational availability at the battlefield, you don't really have systems that are effective and provide combat power. The other thing that I think that I touched on a little bit earlier is interoperability with existing systems. So, hey, what technology can we pull back from the non-traditional vendors are delivering? What technology can we pull back into our legacy systems? And then in parallel, what is the technology that we could push forward onto, say, a blue water craft that would allow them to get to field something very much sooner, rather than trying to deliver some new technology that is going to be a little bit more state-of-the-art, might not be ready to be fielded fully yet, because it could be tough to interoperate with existing systems. So I think there's a lot of opportunity for us to partner in those areas.
Sounds good. And Doc, for scaling fleet capacity beyond what shipyards can deliver, what missions do you think the Department of War believes autonomous surface vehicles or vessels should replace or absorb, so that exquisite manned combatants are freed for higher-end roles?
Yeah, I think the Department of War, particularly the Navy, are still trying to figure out what those roles could be, or what mission sets they can be. So if queried, I would offer that when you go into autonomy, a couple things are really important. And in the just general world of autonomy, if it's too simple, too dirty, or too dangerous, we make it autonomous. Those areas, I think, are areas we can focus on. Particularly, I'll just go with the simple. Or I was chatting with a warrant officer earlier from a DDG. I said, how many times have you been out on mission going, why the heck are we here? We're just burning holes in the sea space to do some general ISR. And he said, too often to count. So those roles, I think those mission sets are where the autonomous system world can absorb that effect. And I would offer in those areas, they would be in choke point control, particularly in the Baltics, in the Bab el-Mandeb, outside of the Suez Canal, in the Gibraltar, anywhere where you have something that you want to look at. Particularly, you want to look at even commercial vessels that are going to be dragging the bottom as we start to talk about our interaction with underwater cabling. They're able to see and then use some sort of effector with a collaboration with partnerships. The reason why I like, and I want to be, I'll just say it now publicly, thankful that we're here to chat, and AFCEA and the Institute have invited me to be here. This collaboration and these discussions with industry help these, I'll call them smaller non-traditional companies, to integrate with our industry partners, large and small, to develop capabilities that can help out in that process. So now we're able to take a look at that. That's one area. The second area I mentioned already is a high-value, need-it-now logistics sustainment. That can be, and I'll offer that MSC is dated information, it's about a year and a half old, but about 90% of our Cat 3 and Cat 4 casualty reports, CASREP, said degraded capability of a ship are very small, less than 50 pounds. And generally speaking, we either put a manned platform to go ashore, and you have to get close, or you wait for other big gray hull to bring it out to you, which is generally speaking about a week, having been a guy that drove around big gray ships. We need to shrink that time frame down. And so those are things that can be absorbed in the autonomous fleet. Some things that they're force multipliers to, I truly believe that we need the big gray ships, and I'll say it right now, we still need aircraft carriers. But to get into how we can complement and create force multipliers are in different areas. Those would be in like a picket fence in the Red Sea that are helping and assisting and providing sensor support to larger vessels where you need a manned command and control aspect. They can provide kinetic effectors, they can be magazines more forward, or in terms of an Indo-Pacific fight, they can be magazines with capabilities that are tagging other silent vessels that are out there marching around that are threatening, with capabilities that can threaten them and capabilities from those vessels that are keep our ships outside of the adversary's weapon engagement zone, but keep a capability inside of our weapons engagement capability. I think those are areas that are really important where, as a start, that's where we can go to. And I think we need an 80% solution now inside of the force employment window and build the airplane as we continue to fly, where we integrate greater capabilities in terms of swarming, greater capabilities in terms of getting to, depending on which scale you look at, but there's 4 and 5, where we can go to, or 4 or 5, depending on which one you look at, where this is off on its own. I gave it a mission. It is truly in mission control. It's going to go out and execute, come back and report. And if it needs other buddies, it's going to request them through that in a multi-domain atmosphere using surface, air, or subsurface capabilities that it's going to work to communicate. That's where we want to get to. I think that's a North Star, but I think that's inside of the force design window as opposed to something that's inside of a force employment window.
Yeah, I'll tell you 2 quick vignettes just to back up that point. I see Colin Coroner out there. I think Michael Brasser was out there. He took off, so we won't mention him. The first Commodore of Task Force 59, the second Commodore of Task Force 59. And when Admiral Cooper had no assets with which to really monitor his battle space when he was 5th Fleet Commander, and you started putting unmanned assets out there, and quickly he was then sending me photos of, look, here's a photo of a ship that I had no idea, Chinese Renhai, a Dow, whatever. And he had no manned assets with which to do that. So it wasn't a DDG, it wasn't an aircraft carrier, but it was more than he had. And number 2, I remember talking to the CEO of DDG 1000, and I said, would it help for you to have like a USV that could go out ahead of you and scout? And he said, did you notice the shape of the ship? It's meant to be stealthy, so of course I don't want to radiate anything. So yeah, it'd be a dream to have something out in front of me that's sending me things back. So. Okay, so let's assume that the people out here listening are decision makers and they've bought into your vision. They think that, maybe there's something to naval power, and maybe there's some congressional staffs, there's CNO staffs, whomever. What would you want to say? Like, look, I think Sebastian said it well. Like, look, I got the thing ready to go. What is the thing, and I'll go right down the line, what is the thing you'd like to tell all these decision makers? What is your impediment? What can they do for you so you can bring the capability that we so badly need?
Oh, I think, as you can hear it in my accent when I talk, we are a French company with only US subsidiaries. And we've been in every exercises where you wanted us to go. We've done everything. We've done TF-59 3-time, 4th Fleet, TFX, REPMUS, and so on. And what's next? So the path to transition from these exercises into real operation contract is not easily readable. Is there a front door somewhere? Who should we be talking to? And should we set up a joint venture? A strong partnership with a US company? And today, everything is on the table on our side.
Right.
I think within the window of medium unmanned surface vessels or the MASS program, there are a lot of very capable suppliers who are going to have holes in the water this year. Where I think we're a little bit behind is thinking about some of the payloads and sort of some of the interoperability for these vessels with the existing fleet. And so we're going to get these out pretty quickly. We're taking some of the same talent that has produced the autonomous cars like Waymos that are already operating in San Francisco and in Austin and in other places like fully autonomously. So we're taking that tech and now we're applying it to ships. But now in terms of serving the missions, you're going to need the payloads. And not only do you need the payloads, you need to test them, you need to marinize them. And I think there's a bunch of different opportunities that are out there, but I think it's going to happen a lot faster than people expect. And so for any of the decision makers, start to think about the payload so we can get the most out of these platforms.
And Laura, before you answer, start thinking about your questions, because we'll have maybe one more question. If people in the audience have some burning question you want to ask, start thinking about it. So, Laura?
Yeah, I'd say it's alignment around the moving fast and the risk tolerance that it takes to do that. We are going to have things that don't go right. We've got to learn from that and move out fast on that. With things that require certification, we've got to learn how to do that on the fly as we're learning, building, testing. It's got to be a seamless process, and that alignment has to be from OSW down to the program office if we're going to move fast. So, you know, that authority to work fast is really what's required.
I can't see you down there. So, Nathan?
Yeah, I think it's two items. It's first, it tends to be the case that autonomy, when it's discussed, is pushed down to the platform level and part of the platform. But that is difficult when you're thinking at the level of the fleet and the intelligence of the fleet. So first, thinking in terms of how do we bring mission autonomy to these systems? How do we avoid relegating that to specifically a set of platforms, but thinking across the fleet and how we're able to roll that out in its own acquisition strategies, in its own ways of integrating across many different types of platforms. And I think there's a lot of great progress there. The modularity, the open architecture is what was called out with Mask earlier, but continuing that good progress to make it possible to bring mission autonomy at scale across the fleet versus on the per platform basis. And then I think on the topic of speed and speed of execution, the reality is, as was called out a moment ago when I was asked, where are we in terms of the edge level intelligence operating out in the field, we are limiting how we are actually operating in terms of the sophistication of the intelligence to ensure that what we're doing always remains within bounds and confidence measures and has a predictability around it that is well understood within the context of the state of the art. We're incorporating humans in and on the loop in order to provide positive identification. And so as systems are thinking for themselves and reading and reacting, they're also limited in what they can actually do because of those constraints and our understanding and our ability to keep pace with innovation and technology. The reality is AI is transforming the entire landscape at a pace that well extends beyond what we can actually keep up with from a policy perspective. What used to take 24 months now takes 2 months. What used to cost $10 million now costs less than $100K. We can now go out and integrate HiveMind onto new platforms in 48 to 72 hours in an operationally relevant environment. And the fundamental landscape in terms of how we create these systems, how we write the software for these systems, how we even think about DevSecOps is just fundamentally changing. And so we really need to think about that because that will be an underlying rate limiter. We will be limiting the intelligence that's running on board these platforms, their ability to read and react, their ability to operate as an intelligent fleet. And if we do not address that, we're going to be hamstringing or slowing ourselves down. And it's not clear to me if others or adversaries will be doing the same. And ultimately, in future fights, in order to dominate, we need to have the most intelligent fleet. And it would be unfortunate if we're rate limiting that intelligence because we're not able to keep up with the advancement and the innovations that are emerging.
Greg?
Yeah, I would say help us deliver capability faster by accepting things before they might be fully complete with meeting all the requirements. Particularly when we talk about in the development cycle, I think I can get a capability out 80, 90, 95% hardware specifically complete in a very rapid cycle. I think we spend a lot of time and a lot of money trying to close on that last 5 to 10% of hardware capability. And a lot of times that's corner case requirements that'll never be needed or never be used. So we spend a lot of time closing on those things before our capability is fully delivered. So I think if we can, assuming it doesn't make it combat ineffective, it's not unsafe for use, I think we can deliver things much sooner as long as we're willing to trade off some of those smaller requirements or corner case requirements so we can get something out to the fleet, 85% capable.
Doc?
Yeah, so I liked what Greg just mentioned. I would say inside of that 80 to 85% has to be the core capability that you're looking for.
Yep.
Because we have a history of failed programs in the Navy. And I'll say the first one is aviation. If you remember back to the flying Dorito chip that never really flew called the A-12. Inside of that mission set was the 80%, and we never got there. And we fought, and it got just way too expensive, and we had to cancel the program. I would say we got ourselves inside of that same venue with, I'm not particularly well versed in it, but the Constellation frigate is now, on the chopping block. So we have a recent history and an old history with it. We have to make sure that we get what we need inside of that 80% and be able to take some risks to push that forward. And I think now with the RCO and the PAE system, as it's being developed and built, they need some early wins in the process that gets inside of that 80%, that lets folks in industry here work on that solution set for them inside of what is a, I'll use an industry term for a bid, which is a P-win, but they need to have that P-win in their office space that's greater than, I'd say, we say mostly 0.5, well, then we're all in on it. But I think they need to have something that's more like a 0.7 or so in their aspect, because that's going to give them the credibility to keep moving forward with, the higher echelons and the authorities that give them the money. And I would also say that they need to do a little better talking with the folks that give them the money in terms of what they do and not surprise them with the new acquisition system.
Great. So, one of the first slides I showed, we talked about Russia, Ukraine, and one of the criticisms you get in the unmanned space is you guys are way over indexing on Russia, Ukraine. That's a very specific fight, and it's not really applicable. What would you say to somebody who says that? And I'll let anybody who wants to take that on. And how does it apply to the South China Sea, the China-Taiwan fight? Is there any applicability, or are those just completely separate? What would you say, stop focusing on Russia, Ukraine? Anybody want to take that?
I'll jump first because I mentioned it earlier, which is we have to have that capability right in their face. But if we have that capability, inside of the inland waterways of the U.S., that's not really a credible capability in their face that makes them question or be concerned about where it is. It's a great capability when, I would offer that they have, and we've seen it before, our adversaries have a great capability to get inside of our logistics system and prevent that movement from one place to another, or at least delay it, so that they would be able to move forward. It needs to be in a capable spot to create an effect that would be desired. That's my push on it, right? If we get the volume, that volume has to be somewhere that it matters.
Anybody else want to take that? Go ahead.
So my co-founder, Austin Gray, when I first met him, he'd actually just spent a summer in a drone factory on the front lines of Ukraine. And his takeaway was not, we need to build what's in Ukraine. It's like, wow, technology and unmanned is changing the game. How does this apply to our fleet? And so I think we need all different types of USVs, but for us, when we design our kind of platforms and vessels, we're thinking about the range and the requirements for the Pacific. And so we're not building exactly what's in Ukraine, but I think it's just, we're trying to say, things are evolving so rapidly, if you don't adopt technology and think about how it can change the fleet, then you're going to fall behind. And so I think there are lessons from Ukraine, but doesn't mean do exactly what is happening in Ukraine.
Anybody else?
Yeah, just building off that, the lessons of scaling and the lessons of adaptability. That's what we're learning from Ukraine, regardless of the product.
Anybody else down there?
Oh, I'll add, right? I think that you mentioned the innovation scale, the ability to change and react, because our first response is going to create a counter, and we have to have an ability to counter with greater intelligence, with greater access inside of a denied environment, or their attempt to a deny environment, do a sea denial for a sea control that they want to have in the strait. And that's where we need to be able to move quickly. And that's, I think, one of the cultural aspects that we need to change that we've seen in Ukraine that matters in the next stages of warfighting.
Go ahead.
Yeah, I think another way, if you think about within the maritime context, is there's a spectrum. You have everything from survivable to risk-worthy to attritable to expendable. I think what we're seeing a lot in Ukraine is expendable, unmanned assets that are on one-way missions that are very low cost. And if you think about our nation, we have a lot of very survivable assets, whether it's an aircraft carrier or a guided missile destroyer or a submarine. You don't want to lose them. They are very exquisite, very capable platforms, the best platforms that are out there. But then there's some stuff in the middle too. There's risk-worthy. That's an aircraft. You do not want to lose an aircraft that has a pilot on board. But if you lose it, you can keep kind of getting more aircraft into the field. And then there's attritable. And attritable, I think, is the definition, I don't think everyone necessarily agree on, but there's also this concept about being relatively attritable. So if you think about Ukraine, we need to be able to, if the time comes, to be able to produce a lot and get things back in the field. And so that's where I think about the medium unmanned surface vessel. It's not a one-way platform. It's not expendable. However, if the time comes, you can build a lot of these and get them back into the field. And that's something that we're seeing in Ukraine, that you need to have this kind of, it's not about the first 7 days, it's about the next couple months or something in an extended conflict. Conflict is, how can we reproduce them and get them back in? How do we make sure we have the industrial capacity today to make a lot of them if the time comes? And they don't need to be exquisite, they don't need to be survivable. We're never going to make 20 DDGs a year in the next 5 years, but we should still continue to make as many as we can. But that kind of other parts of the spectrum, from survivable to risk-worthy to attritable to expendable, we need all of it.
Totally agree. I'll make one editorial comment. I was talking to the Ukrainians, and I said, so what should we take away from this? And one of the Ukrainian senior guys said to me, it's your ability to innovate faster, right? Little fun fact, I was in Australia 3, 4, 5 years ago, and they were talking about, it was the 80th commemoration of the Battle of the Coral Sea. And I was curious, because I knew a lot about Midway, I knew very little about the Battle of the Coral Sea, and I walked up to the Japanese ambassador and his aide, and I said, who do you think won the Battle of the Coral Sea? Because you read different things. And he laughed and he said, well, you guys think you won it, we think we won it, but who cares who won the battle? You guys won the war because you out-innovated us, right? And that's exactly what the Ukrainians said. So I agree that your ability, once the shooting starts, who can out-innovate who? And the Ukrainians said to me is, USVs and UAVs, that's not the end point. We think it's going to be robotics. And so your ability to innovate quicker. And I'll ask one last question. Okay, so I don't know if you heard yesterday that CNO was asked something about, where are you in unmanned, your unmanned strategy? And he said, I don't have one yet. I'm still thinking about it, right? So what I took that as, I'm still not completely sold on this, right? I mean, I think I should be sold, but I'm not really sure I want to put all my chips down on this. What would you say to him? What does the Navy or the Department of War need to do to make him more comfortable to say, okay, now I see the viability of what's going on? What do you think the missing piece is?
Hey, Michael, I'll take a stab at the first one. I think there's probably not going to be a choice. I think at some point, in order to scale to meet the fleet's demands, in order to defeat the threat in the South Pacific, I think we're going to have to rely on some, at a minimum, scalable unmanned systems. Are they fully autonomous is to be determined. And the definition of full autonomy is even to be determined more, right? You could send a swarm of 100 different unmanned autonomous drones out, but maybe one of them is the command and control node, and we're controlling that one, and that's talking to the rest of them. But I think that there's probably going to be some requirement to scale to that. The question is probably the time, and then, of course, how much autonomy I think they actually truly have versus is there still a man in the loop in some form or some fashion.
I think autonomous systems, as was just called out, are inevitable. It comes down to the question of just building out that evidence, continuing to innovate, understanding how those tie into the broader ecosystem, and demonstrating through concrete results the impact and implications on the mission. So I think at this point, what you're seeing is this sort of swell of capability spanning many different classes of systems, many different domains, mission sets, and meeting many important combat operational needs, particularly in Ukraine. But the reality is the technology that's being employed there is similar in nature to what we would deploy in a number of other operational contexts. So I think it's just a matter of time, and as we innovate and as we tie this into the broader ecosystem, as we work through questions of auditability, traceability, certifiability, and bringing that assurance and performance to the table with concrete metrics, then we'll see the proliferation of the capabilities at scale.
Yeah, I would say the best way to find the right places to put those assets is to start, in fact. And if I compare to what happened in the commercial domain, yes, at the beginning we had to convince and try to do some very complicated business cases, and at the end, finally, the customer themselves discover, 10 times more things they could do with their assets because they were learning together. As soon as you can adapt them to new needs, then it will come again, and they will discover a lot of applications. There is already some that are really evident, like sending things where you don't want to put man asset, but also when you think of ASW, people were thinking about multistatism for years, but in fact, you cannot put 5 frigates on the field. But with 1 frigate and 5 USV, then from day one you have multistatism, and that's a huge difference. So there is a lot of things, but they must start. They must use it every day.
Sounds good. I don't see any questions out there. Oh, go ahead. I'm sorry. I thought it was like, dude, you're the last thing between now and the happy hour. But
Hi, everyone. My name is Gurchit. I'm a student at Stanford now. I'm also a Navy Reserve Intel officer. Pre-Stanford, was at a hedge fund called Bridgewater Associates, lived in China, did my master's there, scaled a Series C startup prior to that. I have massive conviction that I'll be building a defense tech company for the next 15 years. When this conversation started, you all talked about the sort of intimacy between primes and rising startups. I'm curious if there's room for like very small pre-seed, seed stage startups to also interplay there. So I'd love to get your thoughts on how the ecosystem operates. And number 2, if there are any IP concerns there and how to overcome said IP concerns. Thank you.
Yeah, maybe I'll start there. As a big prime, we look at investing in startups in that ecosystem and technology capability all the time. So there's absolutely room for that. Those partnerships are determined based on needs, right? Gaps, what can be filled. We're not the best innovation engine in the world. That comes from the entire ecosystem. So I think, that's out there. So that's at least answering the first part of the question.
I'll also say the same. The reason we made the investment in Shield Capital was specifically so that they could do those investments for us in the startup side. So from a prime perspective, yeah, but we do individual ones as well. I don't know about the startup. And the IP, I guess you said IP concerns, but your IP concerns are infringing upon our IP? It wasn't clear on the question there.
So for those of you who did hear what he said, he's basically talking about the IP thing. Little small company, big company comes, takes all the IP, and then what's the incentive? So how does a small company protect himself?
So I think there's genuine interest at the executive level from primes to work with non-traditionals. They don't want to steal your IP. They recognize that you might be able to raise private capital, iterate faster, and build stuff in a way that they are not sort of structured to do. So I haven't sensed any of that, those concerns. However, when you talk to a prime, there are many different people, just like if you talk to Amazon or just like if you talk to the Navy, and just realize those individuals have their own equivalent of like OKRs, objectives and key results. And if you're not on the top 5 for that individual of things that they need to accomplish that year, it's just gonna be hard to get their attention because there's a lot of other stuff they're trying to get done that year. But if you are on that top 5, you can make a lot of progress because they can open access and give you access to the customer, for example. But I wouldn't worry about them trying to steal your IP. And maybe that's a broad statement, but I haven't seen any of that from the primes.
Okay.
And I'll say we invest specifically to get access to that information, which was said earlier, right? That's what we want. We don't want to go do it ourselves because we can't move fast enough. We're not built with those systems anymore. We just want access to that data early.
Just a smaller question to add to that, right, from the non-traditional. Generally speaking, you protect that in contract.
Yep.
So, and it's a shared agreement because you come in with that understanding with the prime and their investment, or in my case, I'll say the larger company in our partnerships and joint ventures, that is, depending on where your negotiating rights are, keeps some of the revenue base in your pocket, but you get that the partnership, the access, and the that larger flywheel of manufacturing capability that those companies will bring to you as a startup inside of whatever you bring to the table.
One comment I'd say, and we'll take the last question. So right before I left government, I went to some of the FFRDCs like Lincoln Labs and saw amazing technology. Then I spoke at some of the business schools. And I said, you guys need to get together because there's a bunch of young guys who want to go start defense startups, and you need to talk because there are a bunch of scientists who had really amazing technology that probably needed to be capitalized and exploited. Okay, we'll take the last question.
Hi. Brian Casey from the Pacific Northwest Defense Coalition. I'm here from Seattle. One of the things that we're really focusing on in the Pacific Northwest is shipbuilding in general and building the maritime industrial base. But obviously here we're focused more specifically on the innovation involved in autonomous surface vessels. But regardless, when you talk about a big endeavor like these, sometimes you hear of maybe a whole of government approach, but we're really taking a whole of region approach in the Pacific Northwest to bring all of the stakeholders and the players together, talk workforce, capacity, all of those things. Obviously, I have a selfish interest in the Pacific Northwest. I'm not necessarily expecting everyone here to care specifically about the Northwest or you all, but regardless of the region, what would your advice be on how to focus and bring together the players in a given region so that we can all do that, so we can all be working toward this common goal that we've been talking about here today?
So I think a lot about shipbuilding. I think the challenge is that the Navy today, for like the platform that we're focused on, is looking for commercial offerings. And so they're not being very prescriptive and saying, use this tech, use this shipyard or whatever. I think we're still in the early days. But I think if things unravel and if this technology proliferates a lot faster than most people expect, which I do think it will, then I think you're going to need the capacity of yards all over. And then at that moment, people like myself, who visited some shipyards in the Northwest, but not all of them, would want to come to someone like yourself to get educated really quickly, rather than have to go to each individual shipyard and distribute all the work. But I just don't think, I know that's not happening today, and I don't think the Navy's in a position to go just the way that they're doing the acquisition to tell people exactly what to do, because they're trying to move fast and let those individual companies make decisions.
Not so much my expertise, but I'll say in Salt Lake City based, there's a company there called 47G that's really a defense consortium, and they're trying to do the exact same thing in Utah and the Salt Lake region. Maybe you could reach out to them for some advice on how you could do a similar thing in the Seattle area. I think there's a lot of interest.
So I'm assuming you brought the weather?
Well,
Are we getting the hook?
All right, you're getting the hook. Thank you. I don't
We
have-
need a microphone.
Hello. Okay. Yeah, you're getting the hook. This was a great conversation. The panel did not disappoint at all. Michael and our panel members, we greatly appreciate your insights and your time today. On behalf of AFCEA International and the U.S. Naval Institute, we'd like to present you with a token of our appreciation, Naval Institute Press book, Naval Power in Action by Brent Sadler. Thanks again for your time and your insights. And we want to thank you all and also encourage you now to move to the happy hour on the Horizon networking reception, which is happening here in the exhibit hall and upstairs in the sales pavilion. Please take advantage of this valuable networking time. Enjoy a safe and happy afternoon. We look forward to seeing you back here for the third and final day of West 2026 tomorrow morning.
And understand the guys that stood here or went through the whole thing get 5 drinks. Did you actually stay? Is that what I?
Yep, five drinks on Michael. Yeah. All right.
Thank you, guys.
Thank you all.
Thank you,
Thank you
sir.
all for attending this afternoon's panel.
Thank you,
We
sir.
now move to the happy hour on the Horizon networking reception, both here in this space and in the upper level exhibit hall. Please take advantage of this valuable networking time. Everybody have a safe and happy rest of the day. We look forward to seeing you at this evening's events and back here tomorrow for the final day of West 2026.
Guess I knew it all along. I'd have to come back home. 'Cause this living on the road only made me tired and so. Like a bird without a nest, like a stranger in the night, and my soul cries out for rest, and the end is not in sight. Tastes like sweet magnolia wine, honey dripping from your mouth. that sweet little gal of mine. She's the finest in the South. Now the days are getting longer, nights are getting colder. I just wanna come back home, lay my head down